last latecomers. Good morning, I guess it's still morning, ladies and gentlemen. So I have the pleasure to introduce you Professor Toshio Fukuda, former president of the IEEE, RAS, and currently being with Nagoya University. Work for his whole scientific life with micro-robots and similar things, and it was so nice coming to Prague. And beside other duties here in Prague, he would like to spend a talk on this topic, which was entitled Embodied Intelligence and Robot Future and the Directions according to his experience. So Toshi, the floor is yours.
Okay.
Thank you.
Dobriano. Hey, good morning, everybody. So, today, I'm very happy to be here. Thanks to Libosa. Libo invited me here. He brought me here to Prague. Thank you very much. Also, I just before starting my talk, may I ask you, how many people are members of the I2P? IEE, one. Of course, you. 1, 2, 3, 4. Oh, 1, 2, 3, 4. Oh, no names. Okay, but maybe you can be a kind of I2P members, so you can enjoy some of the talk, kind of activities. Some here, some So you can be a member of those things. You can be you can enjoy some of the kind of activity, such a kind of young professionals. If you're a student, your student membership, you can enjoy the student activity board. Also, you can enjoy such a young professionals, those things. And also, maybe you also enjoy some kind of other kind of regional activity. So here, Czech belong to the region 8. So region 8 means the covering Europe, East, West, and also Middle East and Africa. It's very wide areas. So you can think about it from north to south, west, east, something like that. So it's a kind of a very wide kind of covering such a whole kind of land, so you can have some different type of viewpoint, okay? First, also, I can just tell you, what robot came from here, Chapek 1920. So that's why there's very interesting to come here. So what happened? 1998, I was in Paris. I had a mission to invite the World Expo to bring Nagoya, where I am, Nagoya. Okay, so there's a kind of all ambassador there listening to my talk. Just as one of the kind of mission to give a kind of 1 to 3 missions, while the last mission for science technology to show some kind of science technology to the ambassadors of such a kind of IAB, such a kind of all kind of board of expo. Then I talk about the robot, it's a kind of Chapek, missions those things. After my talk, actually it's organized by UNESCO, okay? UNESCO, then after my talk, one gentleman came to me and took a hand, okay? Oh, you mentioned the Chapek robot, that's great. So he was so happy, okay? So it was 1998 in Paris, the Congress Center, okay? Such a kind of defense in Paris. Okay, it's a new building, like a glass kind of type of new kind of building, defense. So that's a kind of had such a talk. Really, I was so surprised to get such a feedback from those people, and I'm sure he voted for Nagoya. This is a kind of selection committee anyway. So that again, each side bring such a kind of a mission to explain those things. So that's why I still remember such a kind of a such an instance, such a kind of a ambassador from Czech came to me and shake hand. That's a nice thing. Culture back there here. So you are very proud of the robot, okay? That's great. So anyway, that's today I talk about those things, but why I said can I2P is if you can I2P members, maybe you can enjoy some of them, maybe you can ask a Ribo-san to what to do, something like that. Not only is a kind of a, such a kind of robotics automation, there are 447 technical society and council. So that's why I like those things. And also, when I was I2P very active, I created many things. So, like I created I2P transaction of mechatronics in 1996. So because I wanted to bring something, to make something new, journal, okay? So to submit my paper, okay? So let my student to submit the paper. So I created such a kind of a transaction mechatronics. It's still it was 1996, about 30 years ago, okay? But still people cite my editorials, volume 1, number 1, because I wrote a kind of editorial, 4 pages. So the history of mechatronics. That's nice to think those things. Also, another, like say, many other, like I created also something like a nanotechnology council, because I worked with such a nano areas, nano robotics, so small, okay, and such a kind of not microscope, but scanning electron microscope, kind of such a nearly nano areas. That's why I created nanotechnology council, and I was founding president. Okay, it's nice to think, make it as you like. Later on, I made a medal of environment, energy, and environmental safety technology by sponsored by Toyota Motor Company. So that's a medal, environment safety medal, okay, in I2P. So you can see such as all things as you like it. So what that means that you can make use of such I2P platform. So you can make it as you like, okay? That's a good thing about it. That's the kind of thing you can try some of the kind of thing here. There is some many activity, teach, or can summon, and how you can make a kind of your career more beautiful, for example. There's such a program here, you can check it, okay? There are also women in engineering kind of activities here. So it's also nice to have those things, okay? So that's here. Anyway, that's nice. And by the way, I was the president of I2P. Now, membership is 500,000. 500,000 is the kind of members. So I was president. So far, I'm only one from Asia and Europe. So no other people yet from Europe. So you are you can challenge to be a president I2P from Europe. Okay, Region 8. And that's the thing here. So anyway, today I'm going to talk about such a kind of embodiment, such as things, and what I did is so far in the last 5 years, some project, national project in Japan. So really, that's great. So that's okay. I like this kind of idea, such a kind of things, that's a kind of a comfort space. What the comfort space means, I'd like to make everybody would have a comfortable space. Okay? Comfort space is what you feel so comfortable. ジャマはですね、ゲミと引き換えて。 like after drinking a beer, Oktoberfest, beer, eh? They always sing a song, eh? One drink, two drinks, three drinks, eh? You can feel happy. That's a Gimitrika, they say. They are singing a song. I don't know, in Prague, Czech, you have a very good beer from Pilsen. Pilsen, original one. That's why you must have such a good kind of beer drinking. Maybe you feel you become more comfortable, okay? So that's, likewise, what you like is you can make your kind of space such kind of comfortable. Like a family, your house, your family, your kind of laboratory, your kind of institute, or your kind of housing, any place you can think about comfortable. That's important to do so. To do so, like here, like a hospital, if you go to hospital, we don't know where to go, what to do, you're so uncomfortable usually, make it comfortable, okay? With somebody here. So this is something here, come up here, that's avatar, blue and avatar come up here, so to take care of you, where to go, something like that, okay? Or something when you are sleeping, or your office here, inside, outside, something, you need something here, so someone come up such a kind of assistant, pop up here. That's nice. If your avatar come up here, that's nice. Also like at home here, so you kind of outside, inside, something happen. If avatar come up, if you need it, nice. If you don't need it, stay somewhere, okay? Don't come up, okay? Something like that. Or you are driving a car, maybe you need some kind of pop-up. Where to go is a kind of gas station for next one, or have some kind of drinks, something like that. Need something like that. So you need something here. That's a good thing to do so. So what I have done, so last 40, 50 years about the research work is just one page slide. Here, that's a kind of multi-scale robotics. Multi-scale robotics, so that's okay here, that's kind of like a human body, like cell, tissue, organ, animal, group, and also society, human being. That's great. So likewise, how we can make such a kind of similar one by robotic unit, such a non-organic system, okay? So that here, you can make here one, make here, make a node unit, make a module, cluster, robot, make a group robot, then many robot, like a swarm robot or collective intelligent robot for ABDs, okay? So like here, that you can make it. So the user, horizontally you can go there. So I can make some here. I work here, so I wrote a book over here, such a group robotics, also can do here, how you can make a robot looks intelligent. So I work with such a monkey robot. So monkey blanket, okay? Monkey walking, can climb on the ladder, or it is, okay? RoboZoo called, okay? RoboZoo, you can make a zoo by robot like that, okay? Then I wrote a book also, like a kind of little bit millimeter or sub-millimeter or something like that. It's just a little bit small, okay? 0.1 millimeter, something like that. You can work with such a medical robotics. That's great. So you can make kind of medical robotics here, and then later more smaller, 1 micrometer or less than 1 micrometer, 10 nanometer, something like that. You can work on such a micro-nano areas, manipulation-wise. So good, so work here, so that you can work here. This is a carbon nanotube, and the carbon nanotube is very, very strong, strong as a steel. But we can make bending where you can make 3D structures. So that here, standing right here, this N, Nagoya. N stands for Nagoya, sometimes N, okay? That's a carbon nanotube here. That's okay. So something like you can make many robot, okay? So that's the area. So what's important in this here, right, is just kind of a control with feedback. That's all the thing what you need by understanding kind of physical, such a physics underground. Okay? So because if you go there, here, more like here, nano areas, you have to think about such a kind of nano science, okay? Such a tunnel. So today, tunnel effect is very, very popular. Many people receive the Nobel Prize. Okay? Nobel Prize, okay? Something like that. So first one is a Japanese one that he received tunnel effect. That's why when he was some company in Japan, and then later on he moved to IBM. But that's a good thing. So everything Nobel Prize rating. Also here, this one here, the STM also rating Nobel Prize. The French Swiss guy received a Nobel Prize by STM, scanning tunnel manipulator. Okay, something like that. This area is already rating. This area is already rating such a kind of Nobel Prize. This is not. Anyway, this is nice to think of something interesting, or depending on you, or you like it. Okay, that's nice. So, for example, here in this case, I'm in a company. This is this company here. I'm in a simulator. So, kind of everything, your blood vein bigger than 1 millimeter is reproduced in this simulator. Because 1 millimeter means because of kind of a resolution of how to make a kind of your blood vein 3D printer. Okay, that's the reason why. Okay, so that MRI needs, I need MRI data to reconstruct such a blood vein. So it's good for medical application. We focus on that the medical doctors intervention surgery. Intervention surgery means you have something here, brain. All day they open up your skull. Okay, first of all, shave your hair and cut it. You can bone skull, you put here, beside here, then you put here, you put it here, you can bring here, to reach here, to catch here, do something like that. After repairing treatment, you put it back your skull here, okay, restruct, and then you stay in the hospital 3 weeks. Okay? This is a regular process, but we don't do that. We put it here, catheter put it here, boom. Come up here, along the kind of your blood vein, come up here, to here, inside, so here, go right or left, go navigate over there, to over there. So we can have a treatment. Either way, stop the kind of breathing, or stop such a kind of rupture, or such a kind of something happened over there. Okay? Anarrhodium, we say. Okay? It is something like that. You can do that. After that, you can remove it. The next day, you can go home. Okay? This is anatomy. Okay? This is a non-invasive surgery. Okay? Something like that. That's sub-milli technology. Okay? You can do that. Anyway, this is my company. Okay? Selling such a kind of a simulator. Okay? That's a good thing. Anyway, you can do anything you like it. So far, I like it here. Okay, anyway, that's what I can hear. So what I like is something like here. Oh, by the way, just one more thing. Nowadays, I'm working on here, both sides. Both sides mean kind of this is organic here. This is non-organic. Combine both of them. Hybrid. Hybrid here, okay? Making hybrid, okay? So maybe I might be a hybrid person later on if I replace my bone here, okay? Hip bone, in case. So something, it might be kind of such a kind of replacing those things. You can bring your kind of artificial inside the body, or somebody who lost, lose a kind of arm, anthropomorphic, such a kind of artificial arms like that, or leg. It's also kind of a sort of kind of a replacement. Okay, so we call it cyborg and bionic system here. I created those also here, both sides, and also make such a technical committee in ITP, Robotic Automation Society. That's nice. That was the kind of, I made a company and a conference and journal. And the journal is already 6-7 years. The impact factor, I'm an editor-in-chief, was an editor-in-chief till last year. The impact factor just jumping up to 18.1, 18.1. That's great. Because it's a specialty. So that's nice. Okay? So I want to tell the people, if you have such a kind of thing, you can survive until 120 years old. Because if something wrong, just replace it with something new, okay? Something like that. So till you can go ahead to 120 years old. Maybe you say no. You say yes. Depends on your kind of your idea, okay? As you like. It's your choice, okay? Something like that. So that's nice to have those here. So it's a kind of called such hybrid system, okay? Because I have tried to make it always new something idea. So anyway, something like that. So multi-scale robot system. I proposed 1994 in such a way, such kind of emergence individual. How your individual come up here? Then how the kind of the group come up here? How the emergence organized society appears. It's a kind of here, this side, more like such a kind of, this is a side here, the biological system. Here, maybe here, bee, frog, ant, make such a group, so the colony of social insect. That's also kind of interesting. Likewise, why don't you make this kind here so that we make a thing? Algorithm, neural network, several automata, reinforcement learning, there's a group intelligence, swarm intelligence, collective intelligence, depends you like, okay? Europe like more like a collective intelligence. American people like more like a swarm intelligence. So it depends on the kind of group of people. They select such a word, okay? So anyway, so here, they need to consider robot here, something like that. So I like this idea, so that always cell, organ, individual. 3D wise, such a can make such a kind of self-organized robotics, highlight the self-organized system. That's the kind of main structure. Self-organization is your body is a self-organization. Your brain is a self-organization. Neural network is a self-organization. Everything self-organization. Okay. Anyway, that's here. So that way, like that. So you know the kind of my friend, Boston Dynamic. He makes this one. I like him here. So I like him. He always, he's my friend. Okay. That I always he come to my house. I go to his. So we joke together. So this is something okay. But this is Atlas is something interesting, but he stopped to make it anymore. Okay, he doesn't make it. Yeah, the reason why this is a kind of hydraulic system and it's heavy and not easy to maintain. That's why he is. So yeah, so that's it. So you know that. So now this is kind of nowadays humanoid robot is very popular. Running, running. So like here, robot marathon. So that kind of this year, robot marathon was athletic kind of games in August. Running, 100 meter run or something like that. So anyway, that's also nice. Or here, or in Italy, he like a boxing, boxing. That's nice, okay? So nice to have those here. So, oh, by the way, this robot run 2 hours 40 minutes for half marathon. marathon is usually 42 kilometers, right? So it 21 kilometers to 2 hours 40 minutes. But it you think it's slow, less than 10 kilometers per hour. But the robot is much better than I. I can run. So anyway, maybe you can run marathon, okay, full marathon. But you can beat him, okay, no problem. This is like, so anyway, cellular robot, that's right, I wrote book here, and I like this one. So like here, this is something like a human and a robot work together. So robot carries a heavy payload, the robot, robot takes a heavy payload, and man gives just an advice what to do. So like that. So like here, small one, go to here inside, even cell level, we can replace some of the kind of part here, okay? Something like that. Or something here, come up here, many robot and many robot work together, or they work in the network. This is popular now today. Anyway, so that here, so that is this robot autonomous system is very, very, very interesting. Such interesting. Many robots work together. 1, 2, 3. But here there's a kind of robot here, so something kind of synergetics, artificial life here, sociology. In a way, they are all kind of included in the robotics. This is robotic. If you have 2 robots, 3 robots, it's already multiple robot system. Multiple robot system means what kind of autonomy, you can make it autonomous robot, okay? Something like that. So, like a robot, human is very, very interesting because kind of information is interaction, also physical interaction, okay? That's good. So, I like embodied intelligence robot. So that using such a kind of self-organization and co-evolution. How we can make it? So that here, make a human, make a robot intelligent, and through the environment, then human sees a robot, they learn from the robot. So this cross-learning, cross-learning here. So if they can make a kind of circle, then maybe you can make a much better one above, something like that. Here, maybe here, so that here, embodied AI and cognitive AI. Today, people can like chat GPT, whatever it is, they like such a cognitive AI, but we are like embodied AI, or kind of physical AI, or more than like that. That's important to do so. So many people misunderstood, understood such a kind of embodiment AI. Embodiment AI is just not only the kind of taking us sensor information from outside, also think about your brain science, including brain science. That's important to this. Okay? That's the kind of. So this is something here. So this is important to differentiate with such a kind of cognitive AI and embodied AI. That's important to think about. So this is the human collaboration, like intelligent manufacturing-wise, human science, healthcare-wise, human, okay, all kind of new finding solution-wise. That's important. Find a new solution. Many of them, Nobel Prize winner last year received such a Nobel Prize because of the AI, all the things. So that's interesting, okay? By help of such a kind of AI, okay? That's good. Now, maybe in the future, experiment-wise too, the baby can get something new, okay? That's kind of interesting in the awareness. That's important to think about. So, swarm robot, many robots, maybe imagine here, imagine intelligence here, key application, maybe many here, with wide areas, construction-wise, or space-wise, hospital-wise, factory, agri, many rescue. So that's a kind of very important, particularly warehouse management, like Amazon. They need a lot of robots. So that's here important to do so. So that's why I made a kind of choose for the such a moon means like here, like moonshot program. Moonshot program where I used to work. So far, I am still working. The 5 years, last 5 years is here. This is the Moonshot Research Development Program. It's an ambitious goal to attract people and promote challenge our research development project with the aim of resolving difficult societal issues while bringing together with the wisdom of researchers from all the world. Meaning all the world, people get together to find a solution to make it for 2050. My goal is 2050, not tomorrow. Okay? So that I am not interested in such an industrial robot. Okay? I'm interested more others. Okay? That's all here. That's some here. So the Moonshot program is 2020. What I did is AI robot. By 2050, robot can autonomously adapt to the environment, evolve itself, intelligence, and act with human being. It's too big. That's why I put here, breakdown, target 1, 2, 3. So by 2050, I'm talking over 2050, not within 5 years. Okay? Within 5 years, you can ask some company together, go to work together. Okay? But I'm talking about 2050. So developing the AI robot, the human does not feel uncomfortable. That's a kind of such a kind of robot. Also, like here, by the 2050, developed an autonomous AI robot system that aim to discover principles and solutions. That's important. So maybe we'd like to make a robot get a Nobel Prize, for example, like that. Okay? So by 2050, develop the AI robot, autonomous judge act environment, that's difficult areas, like kind of disaster areas, or such kind of outer space, moon, or kind of some others. Okay? Okay, this is something here. So the vision here is 2050. What I made 5 years ago is here. When the baby born here, grown up boy, and study at school and work here, some company, and I retired here from the kind of travel to the grave, whole life. So robot help you. That is here. They know your kind of habit here, personality that's here for the long time kind of practice here. So that here we make it here. So or the robot work here, that they work together with human. Something disaster appear, you go here. Something moon, they go to the moon here, or something work together, make a research work here to make something good result. Well, something, some finding, new solution, okay? Or new material, new drug, whatever it is. Something like that. Here, that's here. So AI, that's like my basic such a concept of my project. That's a kind of top is embodiment, physical interaction, information interaction. This is the first, and this is a kind of 2019, 2020, to attract more people to apply for my project here. So that here, to make such an intelligence here, we need the next AI, next robot technology. To do so, many things come here appear. To sort of AIs, okay? Well, next here, many things here appears. Okay, embodiment here. But important is, what's important? We're looking at 2050. 2050. For here, 30 years, at that time, 2020. So 30 years to go. Now still the 25 years to go. Maybe the time when we, 2050, maybe our technology is too old, or maybe not accepted by society. Who knows? Like RUR, okay? Okay? Think about it. You are the people from Karel Čapek, okay? So you know the robot, RUR, okay? That, think about it. Robot have to be accepted by society. at the time of 2050. So think about always LC, ethical, legal, and social implication all the time. Maybe okay, maybe this is accepted or not. Otherwise, when we make those robots, 20, 30 years later, how we can guarantee your robot will be accepted in the society? That's important. That's why here, and the standardization too. Okay? This is important to see. So anyway, I made a project here, 1, 2, 3, 4, with a budget, it's kind of 200 million US dollar for 5 years. It's a lot of money. And so I have a lot of money. I cannot use any penny for myself. Okay? Believe me, even I have a 200 million US dollar, 5 years, I cannot use anything, penny, one even penny for myself, okay? No drink, no alcohol, okay? Nothing, okay? But just for research work. So I gave those things here, those things, and here, that's here. So that's nice to have those things to make such a robot. Or something like that. Here, this is a kind of scientific one. Also here, this is a kind of soft robot here, but soft, but we need the stiffness inside too. Soft, but also solid. That's good. Okay, important. So that's important. So then that's it. Anyway, this is just solid in Japanese. So just show the picture here. That's a kind of, she wants socks. Put in foot. She can move. She pretends she's okay. This is she cannot do that by herself. So that's why she should to put the kind of socks inside in her or down here. Okay, next is here. Okay, here's the powerful robot. Yeah, that's a very powerful one because you can put so many kilos at 30, 60 kilogram. You can hold the lady or man up there, and also you can bring it here, something like that. Okay, anyway, that's a kind of a strong robot. Strong robot, okay? Try to make a strong robot too. That's actually make it. Anyway, another is a kind of a scientist robot. How the robot find something new with a human? Okay? Interesting. AI can make it. Okay? That's here. So, what's a conclusion? Human AI robot. Preparing everybody can be a scientist with this robot. Okay? No, we can leave anybody left there. Everybody can be a scientist. Okay? With this robot. So that's here. So what we do is here, make a kind of hypothesis here, then make a design, how to make experiment here, the actual experiment done, manipulation robot here, then observe, get the result, observe, and analyze what it is. Then if you're not here, start it. Make a modify hypothesis with the AI here. Let's go to something like that. So if we can make this kind of loop, instead of such a kind of 7 years, 6 years and a half, spend like IBM to find a new drug, we can find it within 1 month, with even in this experiment, just 1 week. They could make something new, okay? Something like that. So that's nice to do so, okay? That's a kind of loop. If the loop work with the AI, make a hypothesis, make an experiment by robot to do that. Loop is so fine. This is something that we have done for 5 years so far. Okay? Also another challenge to go to the moon somewhere, to lava tube. Lava tube is something like a moon in round shape, okay? Surface looks smooth, but inside there is somewhere hole, okay? This is called lava tube, okay? So like a cave somewhere, okay? Maybe here you can have some cave here. So like a cave on the moon. So we try to go to Number 2, because surface is so temperature not so good, inside maybe warm or not so cold, not so also not so radiation. Okay, that's good. Must be a good place to hide. Okay, here make a good place to make a kind of some human to live. Okay, maybe that's why good make it so that we make that kind of so that we expand also inflatable module that with air like that. So thickness is 10 centimeters. Again, such a break, some break to prevent those here. That inch one here, they can move it here, also like this. So in Kansai World Expo, just 2 months ago, we had a demonstration there using this kind of robot here. Then make this robot here. So this is some demonstration in the moon to go over there. So this robot is reconfigurable. Just simple one, make it change a kind of shape as you like. Okay? So anyway, so what I like it in this kind of a project, just not only make a kind of a hardware system, I like more also software. Think about it. AI. Awareness AI. That's it. I like it. Awareness AI is here. That's a kind of intelligence. So awareness is required. Awareness is such a kind of awareness of situation, awareness of accumulation of shared experience, mutual understanding. That's important. To do so, maybe here you need something tactic intelligence, meta-cognition, intentional understanding, what you are thinking about, or kind of awareness modeling. With this one, make sympathy, or the other here, so situation understanding, experience sharing, then we can come up with the science of awareness. So, because if somebody here, big luggage, means something she want to carry it. Without asking somebody help you. That's good. This is gentleman's robot, okay? Gentleman robot, awareness here, okay? That is here. Don't have a demand-based robot. Robot have to do by themselves. That's important to do so. Okay? So okay. Also, awareness inspiration-wise, that here, how we can make it like that. Ribo-san, he's so smart, he has so many experience, so here, so he can have many inventions. 1, 2, 3, 4, okay, 5, okay, many, okay. But this comes from his wide variety of experience. Okay. Also, his kind of way of speed, don't afraid to do something. Okay, something here. So inspiration come up here. Maybe you have some inspiration associated memory. Maybe this is similar to the other. Something like that. You had such an experience already. Okay? So that here. So how we do that? We need a kind of human factor-wise, we are making scientific factor-wise, so we can make abduction. A, B, B, C, that's why C, something like that. Okay? Something like that. So that I like AI, automated inspiration. Okay? Automated inspiration, good. Inspiration, good, okay? Something, intelligence, kind of inspiration. How can awareness AI, inspired AI, make a much more data-inspired approach, make it similar to your brain. That's it. You have a kind of couple chapel, okay? That's amazing. Good word. That's a robot here. So why not? That's awareness AI, inspired AI, give such a cognitive modeling, attention, recognition, consciousness of inspiration, like that. That's important. You are consciousness, you are unconscious. Unconsciousness, you just behave by yourself. Well, okay? Sometimes, unconsciously. Your consciousness will go, maybe, since rivers are here, so I have to be here, behave like that. That's a kind of consciousness mode. unconsciously, maybe you also behave something like that. That's important to think about. That's why that not only make a hardware system, but also important to think about such a kind of more such a different kind of a dimension which American people cannot think about. That's important to think. That's my idea. But so, 5 years ago started this project here. Okay, that's here. I will say here robot A, robot B. That robot A is represent digital copy of such a kind of Taro-san. This is kind of Hanako-san. B is here. They are communicating each other. Okay, instead of kind of here, so they can communicate. Of course, she or he can join, but anyway, let them work so that if they are successful, maybe generate multiple agents from past, present, future, or self-partner, or counter-partner, other anything about it. Maybe we can go ahead here, so maybe very successful. Okay? Maybe this you here, maybe you are grandma, grandpa, already passed away. You can talk with them because the data there, right? There, no data here. You can have some memory, some picture there. So here, but here. So I saw this kind of, I saw this one more than 10 years ago. Now, some people make a business with this software. This is interesting, eh? 10 years ago, I make a career, think about it. Meet a kind of grandpa, grandma, okay? We need, but they can make it today, okay? That's interesting, okay? Something like that. Or something here, you are here. You are the kind of child boy. You make a child boy 50 years back, okay? Oh, what I should do? Yeah, that time I didn't study so hard. Maybe I should study more. Something like that. I don't know. Anyway, you can think about it, okay? Back to the future. Some story, okay? Maybe that's here, interesting here. Anyway, that's a kind of cyborg. Cyborg. I like cyborg. Here, enhanced kind of sensors, tactile sensing, sound here, energy, artificial organ here, what I'm working on the artificial organ here. Then also here, super protection system here. Then here, many kind of devices here. Then at the end, what you need is neuron connection. Neuron connection, internet. That makes you a kind of cyborg. Well, not talking about Frankenstein, but that's nice, okay? If you are lack of kind of, unfortunately, you lack of right? You don't worry, we can make it here, so that's it. So this is kind of my robot, actually this is my robot, monkey robot, okay? This is kind of another creature, okay, from the zoo. Make it here, that here. So that individual here, I work on bio level, micro nano areas, bio here group, here something makes here, and here make a system, whole system work. This is a kind of neural system here. You can make a robot system work so well. So that's here, that here. So one more thing, I like this kind of cyborg, okay? It's not easy to make a human cyborg. It's against a kind of ethical thing. That's why we use a cockroach. Cockroach. You don't like it, okay, cockroach, okay, you can use it. But cockroach is this is size of 5 centimeter, big one, from Madagascar. Madagascar, Africa is big, so easy to put here on the top. So backpack, okay? So backpack here, here, that backpack here, then technology-wise, you can make small, put it here, inside. Okay? Now, it's kind of small, but here, a cyborg insect, and here, here. Here, okay, here. Starting here, starting here. Why you make this start driving, avoid obstacles here? This is good. Good. So, come back here. Anyway, that is why I do like it. This is here. One here is something. Many of the mobile robots face such a deadlock. In case of glass, in case of sharp angle doors, they always have some kind of sort of a kind of a deadlock to navigate. But this one, cockroach, never have a deadlock. They always get away from such a deadlock. Okay, so that's why some exhaust here. Oh, this is just control right or left. Give a signal right or left, right or left. Okay, so then this move here. All backpack was inside here. Okay, that's what here. So here is the water. This water. Then they make a kind of a suit for cockroach. Cockroach is now here. This is underwater. Underwater. Okay? If the cockroach is in underwater, more than 1 minute, they die, like we. Water, no breath, okay? Underwater. So it survived 2 hours. Means they can do that, okay? They can survive inside. Interesting, right? Cyborg suits. Okay? Cyborg, so we can bring it to the moon. Okay? That's good. Okay? That's nice. Or they can make a kind of something like that. Exploration. We can make it a human. Let's make it to the cockroach. Cockroach, okay, right? It doesn't cost much. Just give it some kind of piece of bread, okay? That survive 1 year, 2 years. Don't worry about it, okay? So that's here. So make it here. That's nice. You can see. Here, the signal here. Red one is the signal inside. So this is like a cyborg insect. Okay? That's interesting. So anyway, summary-wise, in the robot system with AI, nice. That's a direction. Not only think about such a kind of everything is a kind of AI, but also AI, what I mean, automated inspiration. That's the next generation. Okay? Today, they will make data for LLM. There will be some limit eventually. But we can think about some kind of other way, inspiration, produce such a data, also reduce such a thing by such a cyborg or embodied. Thank you very much. So I mentioned embodiment of robotics, such a kind of things. And today it's getting more popular. Sometimes it's a buzzword today. But any embodiment. But interesting to talk about. Anyway, thank you very much for your attention.
Okay, Toshio, thank you very much for your nice visionary talk. That puts a lot of isolated problems into context, and I guess we still have to go a long way to reach the capabilities of robots or abilities of robots, like Karel Čapek predicted a couple of 10 years ago. Thank you very much again. And now there is a space for questions from the auditory. So is there anyone who would like to comment something? Is there a question?
Yeah, Bodhi.
Don't be shy. Feel free.
Give some question. Hi.
Would you compare a level of robotics in Europe and China or Southeast Asia?
Yeah. Oh. Okay, Southeast Asia, West Asia, maybe not so many. Okay. Now, of course, except Singapore. Singapore is very can find the people there. They're working so hard. Good. Indonesia or Thailand, I have my former PhD student that I know what they're doing. Malaysia, maybe I have also my PhD student there, so I know those areas. So that's a level well known. But China, it's amazing. When there, China, 20 years ago, or 30 years ago, 1995, it's a really poor country. There's nothing to do that. Even you cannot get any kind of Coca-Cola, even though over there. But nowadays, after 2004, 2008, China is kind of number 2 country in the world in terms of the GDP. Okay, so that's why that kind of still the people have kind of some problem, but here they are very, very good to make such a more kind of constructive way, one way to go. That's kind of interesting to make a goal fast to go this way. So that's a very interesting. The Japanese way, well, let them people work together, okay? Go, you like it. Some people go this direction, some people go this direction. So it's not kind of better doesn't go this way, okay? But in the research way, better here, better direction to go. With many research scientists go there. So that's a kind of amazing here. So human robot is a very interesting for them. Human robot is number 1 in the world, in Japan so far. Last 1998 to 2010, Japan is number 1, 30 years, because of kind of Ichiro Kato, Waseda University is a pioneer, is made such a human robot for the first time in 1977. And moving slowly, mechanically. One step go to was 1 minute, but anyway, static motion. Then 1997, P2 from Honda make it. Asimo come up here. So I used to work together with Asimo Hondas. That's great to 2011. It was so nice to work together. So make kind of a world record of Guinness of running speed, 9.1 kilometers per hour those days. But this is something here. But this is one, okay? Then compare with Europe. Europe also nice to have that kind of thing. You have many projects. Like he has a project. Also, Europe have a kind of EU project, Horizon project. That's great. You are one of the members here. Guy like Aloy, German guy, like TU Milham, make such a kind of such a kind of horizon robot system. He make a lot here, but any other people make kind of other robot here. Okay, you're a human like it. So that's great. So it's good. It's over. Okay, but likewise, there is such a kind of good project. EU, like he has such a project, okay? That EU have such a nice project. They make such a thing. And I can see such a kind of Jonathan Justin, for example, Justin at DLR, Oberpfaffenhofen, such a German space Research Institute.
German Luft- und Raumfahrt.
Yeah. That's a kind of my friend is working over there. Justin, other like here, KIT, Cancer Institute Technology. They're also making such a kind of my friend working on the thing. Still all the right. Young people, old professors working together, same robot there. Also like a humanoid-wise, there are many others, like a French and also like others. I think there are many, but interesting. American people spend more money, 100 times, 1,000 times more investment. They make a robot like a Neo.
You have to convince the politicians, not us.
That Tesla, they make us so good, a lot of money here. So they can, we cannot compete with them with such a 1,000 times more investment. Yeah.
Yes. By the way, when we were mentioning the EU projects,
Yeah.
what comes to my mind is yet another question,
Yeah.
which is actually coming from our negative experiences then. Because years ago we had a project on evolutionary robotics, trying to work on the cell or component level, like building hundreds of small robotic cells,
Yes.
which should develop into robotic bodies, giving the robot the final mechanical organism capability to survive. So
Yes.
actually to crawl or climb to get to the charger and charge the battery.
Yes.
And so we try to make the evolution with those mechanical systems.
Yes.
And very soon we came to a conclusion that the lifetime of the mechanical solutions, it's so short, you cannot learn anything in that period. So we switched to simulation, but still you don't have enough computational power to simulate the evolution. So what do you think about the complexity of artificial life and artificial evolution?
Yeah, that's interesting. When I started such a several robotics, it's a baby kind of cell together, okay? It was 1987. 1987, Langton started such a kind of artificial life. That I attended his first conference, okay? That's very interesting, okay? That's kind of based on such a theory of Prigozhin, who received a Nobel Prize chemistry. That's a kind of no equilibrium kind of state. So how we can make those things here? That's a kind of theory behind. But anyway, that's a kind of don't forget such a kind of such a complicated kind of no-equilibrium reaction system, but that kind of important is such a kind of how we can think about such a kind of life, something like that. The important is before that, what we did is I'm a kind of control guy, okay, control theory guy. So those days up to there, we always attention such a kind of proof of star read. But now artificial life, you cannot prove anything, okay? No proof of star read, okay? Nothing, okay? That's like a Darwinian way, who cares, okay? So that's the thing here. So that is one of the kind of evolution. That's it. That's it here. So it's very interesting.
It's a big question and big problem.
Yeah. There's no any good solution, good answer, but you can have your own idea what to do. That's a kind of important thing.
So if anyone has a solution to that, shake your hand,
Any
your hand and tell us.
interesting.
So, ladies and gentlemen, any further questions?
Hi, go ahead. We have two gentlemen.
Yeah, I wanted to ask, when you talk about like intelligent robots being able to think for themselves and think of a solution for unseen problems, would you consider it like a general artificial intelligence, like the intelligence that is able to reconstruct itself, update itself without a human interaction?
Yeah.
And if so, what is your opinion about the doomsday scenarios that, like the Skynet or stuff like that, that it will enslave us and, if you know what I mean, like
No.
the best scenarios.
I like more good scenario. That how we can make a train such a robot, okay? Then we thought we can train, we can let a robot learn how to do that. Then now we can learn from robot, okay? So we can make so we can have some group or what I mentioned, okay? Robot, human, robot, human, come back here. So that's a group, okay? So if we can make a group, we can positive way, we can go spiral up, okay? that's a kind of I like such a kind of positive way. Okay, what you said is negative way. Okay? Maybe it's like a bad scenario. That's a good thing. Okay, maybe. But today, there are no such. We should think about how we can make kind of ethical things. That's a kind of robot. But today we cannot make it software, and we have to think about, okay? Because kind of today they cannot learn anything about the ethics, okay? Different level. We human have such ethical thing from the schoolboys, schoolgirls, in the kind of kindergarten, well, high school, to the high school. We know what's kind of important and respect the humanity, so what it is. But the robot doesn't know anything about it. So that's a kind of problematic, so that's a kind of problem. So we should think about such a kind of a good way, try to make a spiral up to go. But there are no good solution yet. We are suffering from many things in some aspect, such a kind of hallucination, something like that. We still have a problem, okay? So we need something to take some action, something like that. Then I hope we are intelligent enough to cope with such a problem. Yeah, if you can have a good solution, let me know. Okay, another one.
Thank you. Victor.
Maybe you already answered a little bit of it. Currently, a lot of cognitive models and especially language models are declining in performance due to training data and other reasons. In your embodied intelligence,
Yes.
you expect the robot to learn from the environment, to learn in the
Yes.
learning loop. Do you expect that there will also, you will encounter the learning curve declining at some point?
I don't think it will be saturated somewhere. It will be saturated.
Yeah.
But then I don't think it's going down. I mean, in terms of such an intelligence, okay? So maybe a learning curve, of course, right? So decreasing, not zero, but decreasing, but still intelligence itself keeping such a thing here. And I don't know how we can go up there, but anyway, we can keep that kind of level. So whether we can go another up level, we don't know. But we need something more good theory than today's such a kind of language model, I guess. Yes. Also, like you see, we don't make use of any kind of semantics yet. Okay. We have such a very nice book. Okay. Okay. We don't make use of such a kind of thing yet. Okay. That's a kind of just. Actually, we don't know the structure of such a kind of language model inside, put here, okay? So that's a kind of problem for me. It bothers me how to make use of such a kind of language model, but simply I don't know the structure of those things. How can categorize, how can structureize inside? It's not open by the company, so that's I have no idea. Yeah, that's good. So that's better to create something new for ourselves to understand the inside structure. Yeah. Sorry about that.
Thank you.
Just we make use of such a kind of generative AI so far.
So, any further questions?
Hi, go ahead.
Please go ahead.
I'm a social scientist, so that's another field of robotics. But my question is if it's usual or normal collaborate in Japan with social scientists like psychologists,
Yes.
ethicists, or philosophers, or if it's in Japan, do you collaborate with
Yeah.
these social scientists or not?
Yes. Yes. LC, in this case, I made a kind of committee in my project. Okay? 1, 2, 3, 4. Actually, I have 8 projects so far. Horizontally. Here, people here get together. Those are assigned my friend who was a kind of good about sociology. Okay? social sciences, such like he very good man, that kind they work together to make such a kind of a thing. But as you know, they are not such a kind of many professors here also, other from university, in such a kind of kind of ethical thing, okay? With this project. So then, of course, we make some kind of brochures at the end. This at the end of my project, but it's not clear. Still, that's a kind of there are not such a clear answer. What the next? What the next? Something like that. There are no such a kind of clear, such a kind of step to go. That will give us some kind of sort of kind of guidance, sort of something like that. That kind of bother me a lot. And also I try to cooperate with those here from others kind of people from France, or French people, also from UK people, to work together. 2-3 years ago, they are such a kind of social scientists. They had a paper on those kind of aspects. That I invited them to come to Japan to here to work together, something like that. That's interesting. If you're interested, let me know. You can involve such a kind of things, and that's interesting. Also, I2P, IEE, we have such a kind of sort of committee also. Also, Standard Association, I2P, have those also such an ethical design, book 1, 2 already, but it's maybe not fulfilled with your kind of idea, but still we are working on such a kind of aspect, ethical design, and the particular autonomous system. Yes. Yeah, it's still interesting. Keep going.
Okay, thank you, Toshio,
Yes.
for your nice answers. Thank you again for the talk, and I guess we can clap our hands again.
Thank you. Thank you.